Hello and welcome to the Engerati studio. We're in Vienna at Engerati Meets, talking about EVs in the grid. David Stokes joins us, Senior Portfolio Marketing Manager at ECI. David, thank you for joining us.
Thank you, Rose. It's great to be here. It's a very inspiring couple of days we've had so far, so it's been very, very good.
You guys are obviously experts in critical infrastructure security and connectivity. And seeing we're talking about EVs in the grid, I'd like to kind of bring our conversation, hook our conversation off that. From the first point of view, being able to handle the connectivity, being able to handle the data coming from EV connections, what's your advice to utilities that are, facing this challenge?
Okay, so firstly, just on a bit of a recap, I mean, the power utilities and generation has traditionally been very one-dimensional. It's been stuff coming from major power generations plants to substations and very linear communications back to control centres. With the advent of, initially DERs, but now even more so EVs, you're seeing a vast number of points in the network needing to communicate back to the control centres. And what was really exciting to hear, actually over the last 2 days here, is the speed that EVs are going to push to change that network, where in fact you're not just only needing to put multiple charging points out in the network. There's a very good chance with all those batteries that are now in the network, in the cars, that those batteries actually can then act as remote storage for the network. So they not only become places where you need to charge them and put energy to, they can actually be places act as energy sources where you need to take energy out of them in times of high demand. And to do that, a linear communication system is no longer appropriate. You need a very, very flexible, dynamic communications network that's able to be take data to and from wherever it needs to be. So within the telecoms arena, we have experience about how to do these dynamic communications network. However, the network's still got to be extremely secure. And you've still got to be able to meet, as you hit the grid and stuff like that, predictable behaviour on that information. So not only have you got to be secure, you've got to be deterministic. And so this is why we've got a term, dynamic determinism, which sounds like a bit of a contradiction in terms, but you've got to be extremely dynamic to meet the flexible needs of the new network, but you've got to be extremely deterministic so that you actually meet the requirements of this network. And that's where you can add in security at these points as well to stop people attacking that network.
Obviously, you model normal behaviour and then you can spot abnormal behaviour. Yeah. Is the kind of EVs sufficiently in use to be able to build those models at the moment?
I think that at this point within the EV world is a point where we will need to work with our existing customers and new customers and how that EV model evolves. Within ECI, we use VNFs, which are software you can download to the point of access, to nearish to the endpoints. Because the VNFs are very quick to modify. It's software, you can upgrade them, you can change them, you can change the rules, you can change the policies. So I think at the moment we model what we know. As the whole network evolves in the way it's used, that the models and the behaviours and the policies and parameters all need to be updated. And the flexibility that VNFs gives is perfect for that. So yet again, I hit on that word flexibility, and that's what's been hitting home for the last day. So sorry to say the word again, but the power world is going to move from a very static to a very flexible world, and the communications network and the security behind that needs to go with it.
How high a threat are EV charging points, that whole infrastructure? I mean, how far into the network could you get?
Once you've actually got into the network, depending on where the firewalls are, how they're set up, but once you've got into a network, you're into the network. So if there's a bi-directional communications path that's allowed at that point, you can get anywhere you like in the network once you're in it. So the clever thing is to make sure that you only get communications that you expect from the network. So for example, if you've got a remote device which is not meant to communicate back to the network, and it starts sending you commands, you know there's something horribly wrong going on there. So you can block that. A more sophisticated approach is that you only allow known communications to come back up. So say it's a sensor, you're expecting a range of parameters to come back. If anything outside those parameters comes back, you can put it in a buffer, and then you can flag an operator or an intelligent system to analyse that message and then decide whether that's actually a security breach or some bug in the remote sensor or something doing that. So we wouldn't automatically discard it because that's really valuable information. But you put it so someone else can then post-analyse the thing to see what it is that's going on there. So I think that's very important to do that.
Interesting. Definitely a space to watch, I think.
Oh, very much so, especially with this proliferation of devices. Very, very much. And the acceleration is just unbelievable.
Yeah, I've been seeing some curves for EV adoption, and it's definitely real. Thank you, David. Thank you for your insights. You've been watching the Engerati studio. Thank you for joining us.